Hello everyone, today we will discuss Merkle trees. So it's a very interesting concept. It's about a trees of hashes. So whenever you have a large amount of data and you need to check any kind of changes occurred in that data or not, like whether your data is in sync or not, right? You have large amount of data, but you are not sure whether any changes is there or not. Like suppose you have a huge data pipeline, right? And here inside there are like thousands of apps, hundreds of apps. In those cases where the changes occurred, how will you identify rather than going through every app? In those cases what happened is we use Merkle trees. So as you can see, this is the construction of the Merkle trees. So this is the base data, right? That is 1, 2, 3, 4. And it is the hash of 1, 2, and 3, 4. It is in the next section, it goes to, one by one. That is, it goes to the next section of the tree, that is the subtree. That is 1, 2, and 3, 4. It calculates the hash of 1, 2, and 3, 4. After that, it goes to another level, that is the subtree of this. That is hash of A, hash of B, hash of C, and hash of D. And once the leaf node has been reached, what it does is it just checks that okay, these hash are calculated, and it checks, okay, we have reached till here, and now we will check the hashes are equal or not. So this is how we construct the Merkle trees, that is the hash trees. So hash of the subtrees or the subnodes that is coming. Okay, so this is how you construct it. Okay, let's check what are the use cases. So the first thing is the data integrity check, right? So how are you checking the data integrity? So suppose this is your main hash, right? That is 1, 2, 3, 4, and it has a hash of, now it will hash out based on 1, 2, and 3, 4, right? So the first node comes as 1, 2, and the second node comes as 3, 4. After that, this hash gets divided, that is 1 plus 2, that is the that is the hash of 1 and the hash of 2. Okay, now it goes to the leaf node, that is hash of A, hash of B1. Now the thing is, what happens is, this is the initial file, right? 1, 2, 3, 4 is the initial file, but when it received, we checked that okay, there is some issue in node B, that is it is coming as B1, it's not B. Okay, in those cases, here you can see that okay, now this specific hash is corrupted. That means the entire file that we have received, that is not correct, right? So what happens is, in this way, what you can do is you calculate the hash of A and you calculate the hash of B, but you have checked that the B's hash is wrong. In terms of C and D, the hashes are correct, but for B, the hashes are wrong. As a result, the correct hashes of A, C, and D are correct, but whenever the hashes of B came, it came as B1, which is not right. As a result, what happens is, suppose this is a large file and it came to us, whenever we are trying to check whether the data integrity has been compromised or not. In those cases, what happens is, we have checked that this is the sub hash of B got corrupted. So that is the reason, that is how you can do it by hashing, due to the subtree nodes, that you check these hashes are equal or not. If it is not equal, that means there is some corruption in the file. So this is one use case of the data integrity check. We will check the next one. Next use case, that is the proving data presence. Okay. So how would you prove that whether a particular data is present in a large data set or not? So what happens is, you have this large data set, that is 1, 2, 3, 4. We are iterating over the same thing, that is 1, 2, 3, 4. We go to the subtree, that is 1, 2, and 3, 4. We generate the hash. We generate every hash till the leaf node, that is the overall structure. Now you see, you have to now you have to prove that okay, we have to prove that C is present in this large hash set. What happens is, what will you do is, we combine this C hash of C with hash of D, and we will compare it with the hash of 3, 4. If this hash is equal to hash, combining hash of C and hash of D, then it will be easily proved, right? That this you don't need to go till suppose this is a big hash, right? There would be n number of levels in this tree, right? You don't need to traverse to every level. What you need to do is you just need to go to the the parent level. You go to the parent level and you figure out, okay, this hash is actually, whenever combined with D, it is actually giving the correct result of the parent node. In those cases, what happens is you don't need to traverse till the root. In that node itself, it will be proved that, okay, it is present. So this is one of the cases, Merkle trees is used, that, okay, you are dealing with large data sets and you want to check that whether everything is in sync or not, or whether everything, whatever the data that you have received is correct or not, or whether you need to prove data presence. In those cases, what happens is you just need to use Merkle trees. Google also uses Merkle trees. So Google has a monorepo, right? So Google's monorepo is basically, it has all the centralized data cluster. So all the centralized apps are there. So whenever a change is required, it generates the hash of that particular app, and it after it generates that, it deploys only that app. It doesn't need to deploy any other apps. So in those, suppose Google has n number of apps, right? How would you figure out that, okay, this app is this app got changed? That means the build got changed and it has a different hash. I don't need to deploy other apps, right? Whenever it detects the hash change, then only it will proceed and go to deployment. So this is how, many people use Merkle trees as well. In Merkle trees, in DynamoDB as well. DynamoDB has multiple clusters, right? It tries to check the data integrity or the high availability. So in terms of those, it tries to check that, okay, in multiple nodes, whether the data state is correct or not, whether the data state is in sync or not. In those cases, what happens is they use DynamoDB uses the Merkle trees as well. So these are the overall concept of Merkle trees. If you like this video, give it a thumbs up and follow for more tech updates. Thank you.